Okay, one last example with parallel axis theorem and moment of inertia. So here we're given the y centroidal location of this shape. So that's what y bar stands for. We can see it's defined here in the diagram, right? So if you wanted to practice calculating that using your composite area formula, you should end up with this 23t over 10, right? Is that distance from the x-axis to the centroidal location. Now the question is find the moment of inertia about that point, about its centroid. And so we can again split this up into composite areas where we have, let's start first with the top. So we'll want to know this one. So that's section 1. And then we'll also then next look at section 2. So for section 1, right, we know that the formula for a moment of inertia will have to account for the parallel axis theorem because the centroidal location for section 1, right, is right here. So here's its centroidal axis, which does not coincide with x prime, right, the overall centroidal location. So we know that we're going to need to calculate for I1, we'll call this section 1, is going to be equal for a rectangle 1/12 base times the height cubed. That's going to be equal to 1/12. The base in this case is 4t, 2t, 3t, 4t times the height, which is just t cubed. Okay? And then we'll need to add in the area, right? So area, in this case, A1, just be the base times the height, so 4t squared. And now the distance, right? So the distance that we're looking for is the distance, right, between here and here, right? So we'll call that D1. So you just have to look at the problem and see how we use the information that we have, right? So we know this part is t over 2, right? So how do we can we calculate this distance? And the answer is yes, right? Because we have this whole thing is 3t, right? That's given. I'm just writing what's already in the problem. And this distance is y prime, right? So this little one, let's call this one a, right? A will be equal to 3t minus y prime. Y prime is already given, so this is equal to 3t minus 23t over 10. Our total distance that we're looking for, D1, though, we'll call this distance, oops, not that one. Remember this here, or here, we already defined it. Sorry, it's getting kind of messy, is B, right? So D1 is equal to A plus B, right? So A is 3t minus 23t over 10 plus t over 2. Combine like terms, and this is going to end up becoming 1.2t. So that's D1. So now, what about the second region? So I'm going to erase some of this just to kind of make this a little bit clearer. You can always go back in the video and look at it. Now let's do this one. So here's our second area. Oops. Call this area 2. And then before we had area 1, maybe that'll, sorry. Okay. And now the centroid, of course, is going to be right in the middle, right, of this rectangle, which has a height of 3t. So we know this distance is 3t over 2. And hopefully you can already start to anticipate what we're going to need. So for I2, same formula, 1/12 base height cubed, except of course now our dimensions are different. So base in this case is 2t times height, which is the 3t cubed. Area 2t times 3t, so 6t squared. And again, the distance is really the only thing, and that's just making sure you understand how to use this y bar. So we need this distance, right, is what we want. This is what we care about. This is D2. So how do we get that? It's just 3t minus, or the y bar, sorry, minus 1/2 3t, right? So D2 is equal to y bar, right, this distance here minus this distance here. 3t over 2, y bar is given by 23t over 10 minus 3t over 2. Do the math, and then you're going to come up with 0.8t. All right, so the moment of inertia about the x prime axis, the centroidal axis for this problem, is then given by ix prime is equal to ix1 plus ix2, which is equal to I1 plus a1d1 squared plus I2 plus a2d2 squared. And if you do all that math and want to check, you should get to a final answer of 14.4 t to the fourth for ix prime. I don't know why my hand's cramping up. 4, and then this is t. All right, that's it.